Welcome to a new video presented to you by APC Mastery Path. APC Mastery Path provides videos related to how to implement the latest artificial intelligence and machine learning within our beloved construction industry. This video belongs to a series of videos that will tackle how to use open source LLMs to build a tool to convert PDFs to a functioning and useful podcast. The system that will be presented in this series relies on four main pillars. Pillar 1, PDFs loading and pre-processing. Pillar 2, writing transcript. Pillar 3, refining the created transcript. Pillar 4, text-to-speech workflow. In the first video, we discussed a part of the first pillar. We showcased how to set up the coding environment, load the PDFs, extract raw text and save that raw text in a file. The output file of this video was a raw text which is uncleansed and contains a lot of white spaces alongside irrelevant text information, page numbers, and the likes. In the second video, we discussed the outstanding part of the first pillar. We used Llama 3.1 billion parameter large language model to make sense of the extracted raw text and reword it to make more sense in preparation for the next steps. The output from this video was a much more cleansed text file which was done by the uploaded LLM of choice. It made its best to remove the white spaces and unnecessary text. This file is now more in shape and ready for the next step. In the third video, we discussed the second pillar. We used the cleansed text which was the output of the previous step to be the backbone of writing the first iteration of the podcast script. In this video, we are going to discuss the third pillar. We will introduce some refinements to the first iteration of the transcript created in the previous step. Having understood how we are going to tackle this project, let's dive in. This project was crafted by the Meta team and they have provided the full code on one of their GitHub repositories that I will be putting the link for in the video description below. I have also created my own refined code and uploaded it to a separate GitHub repository which I am going to be providing the link for in the video description below as well. This will make the process of following through and implementing the project much easier for the listeners. Step 1. Creating an effective system prompt. In the Step 2, Transcript Writer Notebook, we got a great podcast transcript using the raw file we have uploaded earlier. In this one, we will use Llama 3.1-8b Instruct model to rewrite the output from previous pipeline and make it more dramatic or realistic. We will again set the system_prompt and remind the model of its task. Step 2. Import required libraries and configure warnings for model processing. As always, it is quite necessary to start our code by importing essential libraries needed for deep learning model processing, device management, progress tracking, and handling model-related warnings. By setting up these imports and configuring warning suppression, it prepares the environment for efficient and focused model operations. These libraries provide the necessary functionality for working with large language models, tracking progress, and optimizing device usage. Step 3. Select and load a .pkl file for input. Having imported the necessary libraries, it is time to care for the graphical user interface by creating a file selection dialog using Tkinter to allow the user to choose a .pkl file interactively. Once a file is selected, the code loads the content of the .pkl file using pickle and stores it in the variable input_prompt. This approach enables users to dynamically specify their input file, making the workflow more adaptable. Step 4. Initialize text generation pipeline and generate text. It is now time to set up a text generation pipeline using Hugging Faces Transformers library. The pipeline initializes a pre-trained language model with specified parameters, prepares a structured prompt consisting of system instructions and user input, and generates text based on this prompt. We have already defined the model of choice at the beginning of the code. We chose the Llama 3.1 billion parameter model with 8-bit quantization because we are bound by the GPU memory limits. By configuring model properties such as torch_dtype and device_map, the pipeline is optimized for efficient processing. Step 5. Extract and display generated text from model output. Once we have generated a text from our chosen model in the previous step, we need to save the final generated text content from the model's output and to assign it to a variable, save_string_pkl. We can then print the entire generated output segment for inspection. By isolating the processed text, this step prepares it for further use, such as saving to a file or additional processing. Step 6. Select save location and save process data as a .pkl file. Keeping in mind the process of generation of refined text, we are using in this step Tkinter to open a file save dialog, allowing the user to specify the save location and file name for the process.pkl file. After the user selects or names the file, the code saves the process data to the specified location using pickle. This setup makes it easy for users to control where and how their data is saved. The main output of this video is a refined .pkl file which contains the first iteration of the transcript produced in the previous step. The produced PKL file contains more depth and breadth in the conversation. The empty lines are removed and replaced with more depth in the topic at hand. Punctuation marks are added to the conversation alongside words that can express feelings. In the next video, we will be discovering how to make the best use of text-to-speech model to convert the podcast-ready PKL file into an MP3 audio file for the podcast. All the files that we are explaining in this series of video are available on my GitHub repository provided in the video description below.
Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of other videos about fine-tuning large language models and deploying them to OpenWeb UI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RSCS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.